Let's take a look at the standard equation for a sine wave. Now here's our equation here, and this Vt, that's the voltage at time t. This is our time over here, and that's going to be equal to the peak voltage, or the amplitude, the highest point on the sine wave there, times the sine of an angle. Okay, you always have to take the sine or its cosine of an angle, and in this case we're going to use degrees. We're going to use 360 degrees times the frequency, and that's going to be our angular frequency, times the time plus the phase angle, wherever point we are along this curve here. Okay, now a lot of times instead of the degrees they'll use radians, and 2 pi radians is the same as 360 degrees, and 2 pi f is, they use the omega sign for that, the lowercase omega, and that's called our angular frequency. So, and we use that for radians, but in this case I'm going to use degrees instead of radians. And now you can do it in cosine instead of sine. Now sine wave or cosine wave. Now a lot of times in the books you'll come up with a cosine, but this is the difference here. We have a sine wave here, starts at 0. This point rotates around here counterclockwise. This is 0. This is 360 degrees here. And over here we have a cosine wave. It starts at the peak here, and that's 0 degrees right here. It starts at the peak. So if you take the sine of 0 degrees, that's 0. So 0 times our peak value is going to be 0. We're at 0 degrees right here, no voltage there. But in this case, we're taking the cosine of 0 here because we're at 0 degrees, and that's going to be 1, and 1 times whatever our peak value is, that's going to be our peak there. In this case, we're using 170 volt peak. So I've got some examples here. So the first one is at 60 hertz, 170 volt peak, and at 45 degrees. Now 45 degrees happens to be our RMS value, so we'll calculate our RMS value here. Now this period here is it's 60 divided into 1 gives us the time, so it's 0.0166 seconds. Okay, and at this point here at 45 degrees it's going to be 0.00208 seconds. Okay, so we take that to 60 times that, we add our 45, and we multiply it by our 360, and we get this number here, and we take the sine of that, and we times it by 170, and we get 119.99 volts, 120 volts. So that's our standard voltage here is 120, and our peak is 170 volts. So let's see what the peak is actually at 90 degrees. This is going to be 90 degrees right here. See if it's a peak, see if that comes out right. So at the peak, it's going to be 0.00416 volt seconds, and we take our 60 times that plus our 90 degrees times our 360, and that comes out to 32489 and some decimal places there. And if we take the sine of that times 170, that's going to be 169,999, so 170, real close there. These seconds in that, you know, they go on for a long way. So if you know, the more decimals you use, the better, closer you're going to get. And one more thing, 180 degrees right at this point here, that should be our 0 point. Okay, so we take, and that should be halfway between the half of this one, so it's 0.008334, and we take 60 times that plus our 180 degrees times the 360 degrees, and we take the sine of that times 170, and it comes out to 0. Okay, so that's going to be 0 degrees, that's going to be 0, 170, and 120 degrees there. So that's how we figure our voltage on the sine wave there, and this is our cosine wave over here. So yeah, that's all there is to it. Now most of the time you'll see it with a cosine and within radians, but I like to use the degrees. It just seems like it's easier for me to wrap my head around degrees than radians, but either way works. And when you're doing it on your calculator, make sure that the calculator is set for degrees instead of radians, or if you're doing it in radians, make sure it's set for radians. Otherwise, these numbers won't come out right. Anyway, that's all there is to it, and that's a equation for a sine wave. Thank you.